Welcome to Intermediate Algebra video lecture number 15 on absolute value equations and inequalities. So when we talk about taking the absolute value of some quantity, usually a real number x, we denote it by writing a vertical bar on either side of the quantity. So absolute value is written with two vertical bars. Now, the definition that we're going to be working with is as follows. The absolute value of x is equal to x if x is greater than or equal to 0, and it's equal to the opposite of x or negative x if x is less than 0. Now, let's take a second and think about what this definition means. This is a piecewise function, and in the first case, if x is greater than or equal to 0, let's think about what that would mean if we were just working on the real number line. Here's where x is 0. And in the first case, we're saying x is greater than or equal to 0. So x lives somewhere over here. And notice when you take the absolute value of x, if you're in this case, if you're on that side of the number line, then the absolute value of x is just equal to x. You don't do anything at all. So when you take the absolute value of a number that's positive or equal to 0, it's just the number itself. The second case is if x is less than 0. So if x is less than 0, then that means it lives somewhere over here. Okay, that's if x is less than 0. And notice when you take the absolute value of x now, what you end up doing is multiplying it by another negative. Well, when you take a negative number and multiply it by another negative, the result is going to be a positive number. So either way, after you take the absolute value of some quantity, it's going to come out to be positive or 0, but never negative. If it's already positive, you leave it alone. If it's negative, you multiply by another negative and make it positive. You also might have heard in previous classes the geometric definition, and that is the absolute value of a number is its distance from 0 on the number line. And so we wouldn't use any negatives when we're describing distance from 0 in this case, so that's why the absolute value is never negative. Regardless, okay, keep this piecewise definition in mind because you're going to work with it in your later math classes as you advance. But for our purposes today, when we're solving equations and inequalities, the main takeaway that you need is this. Anytime you're solving an absolute value equation and later inequality, you have to break it down into two cases. One based on the fact that the quantity inside could be greater than or equal to 0, and the other that it could be less than 0. So let's look at some really basic examples first, and then I'll give you the process for solving more complicated equations. First one, example A. The absolute value of x is equal to 9. Just by sitting there and thinking about it for a couple seconds, can you figure out what the solution is going to be? There's more than one possible answer, right? Because x could be 9 or x could have been negative 9. Both work. And so I'm going to put them both in my solution set. You have a few options. You could write 9, comma, negative 9. The order doesn't matter. Or you could write out plus or minus 9 if you don't want to write the 9 out twice. All right. That one should make sense. If you had positive 9 and you took the absolute value, you'd get 9. If you had negative 9 and you took the absolute value, you'd get positive 9. So that's how we have two answers. Now let's look at example B. We have absolute value of x equals negative 3. So what number could I stick in there for x, take the absolute value, and then it comes out to be negative 3? Can you think of one? I can't. I don't know what you came up with if you found something, but it's not going to work. Remember, if x is positive 3 and I take the absolute value, it's still positive 3. If x is negative 3 and I take the absolute value, it comes out to be positive 3. So this is not possible, right? You can't have the absolute value of something equaling a negative number. No way, not possible. So what do? You just say no solution. All right, you could write out the empty set this way, or you can write an actual empty set, okay? Just do not put the empty set in there. No, no. I'm just going to erase it. Don't even think about it. Those are your three options. You can either write no solution, write the empty set, 0 with the line through it. That means the empty set. Or you can write an actual empty set. Okay, so what about when these equations get a little fancier? What do? I'll tell you right now. So the absolute value principle for equations. For any positive number p and any algebraic expression x, you see how that's a big capital X? That's because we're taking the absolute value of some algebraic expression. So it may not just be x by itself. It could be like 4x plus 3 or something like that. So if absolute value of x is equal to p, then what you do is you drop the absolute value bars and you write two new equations. You either write x is equal to p or x is equal to the opposite of p, negative p. B, if the absolute value of x is equal to 0, then you just drop the absolute value, set whatever's inside the absolute value bars equal to 0, and solve. The reason you only have one case there is because positive 0 is the same as negative 0. And then lastly, if the absolute value of x is equal to negative p, then there's no solution. Don't try to drop the absolute value bars and write two equations and solve. Your solution will just be bogus. Don't do it. So right away from the beginning, if you notice you have the absolute value of some quantity and it equals a negative number, stop immediately and just put no solution. All right, so let's practice a few together. First one, example A. Solve absolute value of 5x plus 2 equals 7. Now make sure before you get to any step here, right, A, B, and C, you need to isolate the absolute value expression. So that means you want to get the absolute value bars all by themselves on one side of the equation before you decide are you in case A, B, or C and proceed. So I'm looking here, everything looks great. I've got the absolute value all by itself on the left-hand side. 7, yep, that's positive. So I'm going to break this down into two cases. Here they are. First one, you do nothing. So you just rewrite the original equation with no absolute value bars. Or rewrite the same equation and then now switch the sign on the right-hand side to make it a negative 7. Okay, not too bad, not too bad. Now from here, we're going to solve each of these. You should be pretty comfortable solving these. These are just regular linear algebraic equations. So subtracting 2, we've got over here 5x equals 5 divided by 5, so x equals 1. Or 5x equals negative 9, x equals negative 9/5. So these are our two answers. They're both going to go in the solution set. The order you put them in the set doesn't matter because they're both x values. It's not an ordered pair x, y, right? So just separate them with a comma and we are done. Okay, now let's look at example B here. Let me zoom in. Notice in this case, I have absolute value of 2y minus 5 equals 13. So before I get started, I need to isolate the absolute value expression, get that absolute value of 2y all by itself on the left. So what should we do first? Did you say add 5? Good job. So let's add 5. So we've got absolute value 2y equals 18. Now we can go ahead and drop the absolute value bars. So we've got 2y is equal to 18 or 2y equals negative 18. And then last step, divide by 2, so we get y is equal to 9 or y is equal to negative 9. And that's done. So we can go ahead and put them in the solution set. We have 9 and negative 9. Yes, if you like, you can put plus or minus 9. Okay, good, good. Nice, there we go. Why do I always put solution sets and I don't just stop at y equals? Because later on you're going to learn solving more complicated equations where you have extraneous or extra solutions that you don't report in your final answer in the solution set. So I always like to write one out because then it reminds me to stop and think and make sure that all of my solutions belong in the solution set, should get reported. Right now you don't have to worry about that, but it's just that extra step that will make all the difference later on. All right, let's look at example C. We've got absolute value of 3x minus 1 equals negative 7. Now hold on. Can you take the absolute value of something and it equals a negative number? No way. So this is no solution. Don't write anything out, just stop. If you were to try to solve and do 3x minus 1 equals negative 7, and then 3x minus 1 equals 7, whatever you get for x will not be a valid solution and it won't work in the original equation. But you may not realize it because you probably don't stop and check all your answers. So make sure you're on the lookout that as soon as you notice you have the absolute value of something equaling a negative, you stop. Abort mission. Don't even try to solve. Okay, example D. 3 times, that's being multiplied. You see how it's sitting outside the absolute value bars? 3 times the absolute value of 2x minus 5 minus 7 equals negative 1. All right, so to kick things off, we have to isolate the absolute value bars. Don't do anything weird like distribute inside. We want to try to leave alone whatever's inside the absolute value bars. Okay, so let's add 7 first to both sides. So we've got 3 times absolute value 2x minus 5 equals 6. All right, and then I can divide by 3. So now I have absolute value of 2x minus 5 equals 2. All right, very good. This is fine because I have the absolute value of something equaling a positive 2. We're allowed to do that. Let's split it into the two cases. So we either have 2x minus 5 equals 2 or 2x minus 5 equals negative 2. Beautiful. Now we solve each of these. So 2x, if I add 5, is going to equal 7. So x equals 7 halves. Or 2x is equal to 3. So x equals 3 halves. Leave everything as fractions in simplest form, fully reduced, but no decimals unless you're asked for it, okay? So 7 halves and 3 halves. That's our final answer. How we doing? Okay. If some of you were nervous when you looked at the original equation because there was a negative 1 on the left, don't jump the gun and think no solution too soon. Remember, you don't make that decision until you've isolated the absolute value quantity. And since 2 was positive, once we simplified there, then we were allowed to keep going. Okay? Let's do one more. Let f of x equal the absolute value of 1 minus 2x over 3. Find all x for which f of x equals 1. So they want us to set this function f of x, which is equal to the absolute value of 1 minus 2x over 3. They want us to set that equal to 1. All right, well, the absolute value quantity is isolated. So let's go ahead, drop it, and write our two new equations. We either have 1 minus 2x over 3 equals positive 1, or 1 minus 2x over 3 equals negative 1. How do we start? We're going to multiply both sides by 3. So then 1 minus 2x equals 3. Subtract 1, negative 2x equals 2. Divide by negative 2, so x equals negative 1. So I solved the first one. Or, again, multiplying by 3, 1 minus 2x equals negative 3. Subtracting 1, negative 2x equals negative 4, which would mean x is equal to positive 2. So here are my two solutions. -1 or 2. We could put a solution set if we want, but the directions weren't solved. So if you just stopped here, that's fine. We answered the question. All right, now let's get a little fancier, right? I feel like this is just becoming a little too easy. We're professional already. Sometimes an equation involves two absolute value expressions. Oh my goodness. In this situation, there are, again, only two cases that need to be considered. If the absolute values of two expressions are equal, then either the expressions represent the same value or they are opposites. Okay, and so how would you set that up? Well, if they're the same value, the exact same value, then you would just set the first quantity inside the absolute values equal to the second. If they're opposites, then you would set the first equal to the opposite of the second. So you would still have, if you have absolute value of A equals absolute value of B, then your two cases are either A equals B or A equals opposite of B. You could put the negative on the left side instead, but since we're so used to putting it on the right with the constant for the first cases that we looked at, let's just keep it there so everything feels familiar. Okay? Good. So let's look at a couple of examples. Example A, we have absolute value of 3x plus 5 equals absolute value of x minus 6. So two cases again. If they are the same quantity inside, then you would just have 3x plus 5 equals x minus 6. If they are opposites, or 3x plus 5 is going to equal the opposite of x minus 6. Do you see what I did there? So I have a negative sign in front of the whole right-hand side, but you've got to put those parentheses, okay? Otherwise, you will not get the correct answer in the end. So let's see what's going to happen here. Let me solve the first one. Let's subtract x. And now we have 2x plus 5 equals negative 6. If I subtract 5, now I have 2x equals negative 11. So x is negative 11 over 2. Or, now watch this, this is going to be 3x plus 5 equals negative x plus 6. Do you see that? Watch out for that extra negative distributing. Let me go ahead and add x. So we've got 3x plus 5 is equal to 6. Oh, you know what? I didn't add x, huh? I wrote it down and I didn't do it. My goodness. 4x plus 5 equals 6. So subtracting 5, 4x equals 1. X is 1/4. So those are our two answers. We've got negative 11 over 2 and 1/4. See, not too much worse. Only thing you got to remember is put those parentheses on the right-hand side so you distribute that negative. Okay, example B. Why don't you guys go ahead, pause the video, try it on your own and see how you do. There's a little twist on this one, okay? So if you run into something a bit strange, don't be alarmed. Okay, did you pause the video? I hope you did. Let's compare our answers. So, case 1, if they are the same, then that means 6 minus t is equal to t plus 7. If they are opposites, then that means 6 minus t is equal to negative, and then put parentheses in front of the t plus 7. Okay, now let's solve. So in the first one here, I'm going to add t. So we've got 6 is equal to 2t plus 7. And then let's subtract 7. So then negative 1 is equal to 2t. That means t equals -1/2. All right, now what if they are opposites? So then that means 6 minus t equals -t minus 7. And then this is where maybe the strange part happened to you. So if I add t to both sides this time, notice they cancel out completely, right? Boop, boop. So all I'm left with is 6 equals -7. Now you guys, does 6 equal -7? No. So this is a false statement, not true. So that means there's no solution. Not no solution to the whole equation, just to this second case. So the only answer that we're going to report this time is t equals -1/2. We only have one answer. Oh no, are you a little sad about it? It's not your fault, okay? All right, that's it. -1/2, you're our only hope. Very good. Okay, how are we doing? Now we're going to take a little break from equations and move on to inequalities. Okay, so inequalities involving absolute values arise frequently in higher level math courses. And most likely that's where you're going to be going later down the road. So to start off our discussion, we're just going to solve a couple absolute value inequalities, but we're just going to do it intuitively, kind of think about it, look at a graph, and then I'll give you a process. Okay, so example A says the absolute value of x is less than 2. What I want to do is draw a number line. And I want you to tell me where I can shade all of the numbers whose absolute value would be strictly less than 2. Well, you could go up to 2 but not include 2, right? Because it was less than, it wasn't less than or equal to. So that's why I put parentheses on the number line. And you can go all the way down to where? That's right, -2, but you wouldn't include it. Good. So how would you write out this final answer as an inequality without absolute value? Isn't this the same thing as just saying x is between 2 and -2 that way? Good. In interval notation, it would be -2, 2. What if the inequality was facing the other way? So look at example B. We have the absolute value of A is greater than or equal to 3. So let's see here what's going on. Here's 0, 1, 2, 3, 4, -1, -2, -3, -4. Can you tell me where I can shade so that the absolute value of whatever I'm shading would be greater than or equal to 3, excuse me. So you could include 3 this time, right? So I'm going to put a bracket, and then it has to be greater than or equal to. So I'm going to go this way to the right. And then I could also include -3 and go this way to the left, correct? So how would you write that without absolute values? Just what's the interval and set builder way of writing out what I just shaded? Okay, so you could write either A is less than or equal to -3. That's that first shaded area. Or A is greater than or equal to 3. That's the second shaded piece of the graph. In interval notation, this would be -infinity to -3 bracket union, right? You put union for or, bracket 3, infinity. Always parentheses on the infinity. So those are your options. Notice the solution looks differently depending on if the inequality was less than some number or greater than some number. So here is the process or the cases for solving absolute value inequalities, all right? For any positive number P and any algebraic expression X, here are your two cases. If the absolute value of X is less than P, then you drop the absolute value bars and you write X is less than P and X is greater than -P. And as you noticed in part A, this can be combined into just saying x is less than p and greater than negative p. You can make a compound inequality that way, the little sandwich, okay? If the absolute value of x is greater than p, then x is greater than p or x is less than negative p. Now you might be saying, what in the world is going on? Okay, so look at the two cases. I'm gonna box them up this way. That's one, that's the other one. Okay, it's very similar to when we had the absolute value equations. You're gonna drop the absolute value bars. Now look at this first inequality. It looks exactly the same as the original, just no absolute value. Now look at what happened with the second one. I flipped the direction of the inequality and I add a negative to the other side. Look at case B, same thing is happening. So greater than p, this stays the same, do nothing. Then in the second one, you have to do two things. You flip the direction of the inequality and you add a negative. So the first inequality, leave it alone. Second one, you do two things. Now I want to point out one other important fact. This first one had the word and between the two inequalities, which is why you're looking for the overlap, and that results in this case. The second one, we use or. How can you remember? Well, notice we had absolute value of x is less than p. So think less than, okay? So less than goes with and then this is absolute value of x is greater than p. So this is great, oh yeah, or, great or. Okay, it's a little cheesy, but it should help you. Now, let's think about what it would mean, however, if p is negative. So if we have the absolute value of x and it equals p and p is negative, just like we looked at in the previous examples, we would have no solution. What if you have the absolute value of x is less than p, and again, p is negative? So think like absolute value of x is less than negative 5. Is that possible? Can you take the absolute value of something and it be less than a negative number? No way, there's no solution. Any number you put in there wouldn't work. Even if you put negative 100, after you take the absolute value, it becomes positive 100 and it's bigger than negative 5. So this is not happening, no way. Now what about the last one? What if you have absolute value of x is greater than p and p is negative? Well, then you could put anything you want in there for x, because after you take the absolute value, of course it's going to be bigger than a negative number. So all real numbers would work. You don't even have to try solving it, okay? Just relax. And in interval notation, you would write negative infinity to infinity. Okay, so here we go. Let's look at some examples. And before we get started, remember, just like the last set of equations, you have to isolate the absolute value first, okay? So solve, graph, and write your solution in interval notation. So we've got absolute value of 2a minus 5 plus 1 is greater than or equal to 9. So we're going to go ahead, subtract 1 first, and now I have absolute value 2a minus 5 is greater than or equal to 8. Now it's time to drop the absolute value bars and write out my two cases. Case 1, do absolutely nothing. So 2a minus 5 greater than or equal to 8. Case 2, you have to do two things because we were so lazy on the first case, we have to make up for it. 2a minus 5, watch, less than or equal to negative 8. Did you see the two things? Flip the sign, add a negative. Now, what word goes in between those two inequalities? Correct, it's or, because the absolute value is greater than 8. Love it. Now let's solve each one. So we've got 2a greater than or equal to 13. So A is greater than or equal to 13 over 2. Or 2A is less than or equal to negative 3 if I add 5. So, or A is less than or equal to negative 3 over 2. Now let's graph this. Be careful, negative 3/2 is over here. 13 over 2 is over here. A is greater than or equal to 13 over 2. I'm going to include 13 over 2, shade to the right. Or A is less than or equal to negative 3/2, so you include it and then shade to the left. And then in interval notation, I'm going to have to write two separate intervals, right? However many pieces of the graph are shaded in, that's how many intervals you're going to have. It has to go in order from left to right. So we're going to go negative infinity, negative 3/2 bracket. And then instead of writing or, you put u. That's an ugly little u. I got to do it nicer. Hold on. There we go. Yes. 13 over 2 to infinity. Bada bing, bada boom. Do you like it? Good, good, good. Box it. Lovely. Now, let's move on to another example where the case is going to be a smidge different, okay? So we have absolute value 3x plus 7 is less than 12. So here you go, two cases. First one, do nothing at all. 3x plus 7 less than 12. Second case, 3x plus 7 greater than negative 12. And what word goes in between? That's right, this time it's and. Why and? Because the absolute value was less than 12. Okay, let's solve each of these now. So subtracting 7, I'm going to have 3x is less than 5. So x is less than 5/3. And 3x is greater than negative 19. So, and x is greater than negative 19 over 3. Now let's graph this. Don't worry about these fractions, right? All I care about is, hey, negative 19 over 3, that one's negative, so it's going to be on the left, and 5/3 is over here, right? Don't sweat it. So let's graph. X is less than 5/3, so that means parentheses, shade to the left, and x is greater than negative 19/3. Let me do that in pink. Parentheses, shade to the right. And then remember, when we have the word and, we're looking for the overlap, the intersection. So where do you see both purple and pink on the number line? Yes, right here in the middle. So our final solution in interval notation is just that portion in the middle where they overlap. So that would be from negative 19 over 3, comma, up until 5 over 3. All right. Now, you could take a little shortcut, but only if you feel comfortable. I don't want you getting overwhelmed, but let me show it to you, okay? As soon as you notice you have the absolute value of something and it's less than a number, okay, that you're going to be using the and, you can kind of skip this whole part and make your sandwich inequality right off the bat. Here's the sandwich. Get ready. 3x plus 7 less than 12, and, so just throw it on the other side. It has to be facing the same direction as the other one. And then you put the negative 12 there. I know. Then you can just solve it all at once. So subtracting 7, you would get 3x less than 5 greater than negative 19, and then divide by 3, negative 19 over 3, x 5/3, graph it, bam, same thing. And it cuts to the chase a little more because you don't have to look for the overlap, okay? So you're only allowed to make this little sandwich inequalities for the absolute value ones that are less than some number. If it's greater, you have to do or, they have to be two separate ones. You can't combine something like we did in example A, okay? Good, good, good. A couple more examples. Example C, absolute value of 7y minus 6 is greater than negative 6. Ooh, there's a negative on the other side. Okay, this is one of the special cases. It's either always true or it's never true. Which one is it? So when you take the absolute value of something, when is it going to be greater than -6? Did you figure it out? I'll give you a little secret. If you're having a rough time figuring it out, just pick any old number and plug it in for a y, plug it in for the variable, and see if it's true or false. Okay, this one's always going to be true, right? When you take the absolute value of something, it's going to be bigger than a negative number. But say you just too nervous, can't remember, pick a number. What do you want to plug in? How about 1, right? Isn't 1 so easy to plug in? So let's check. Absolute value of 7 times 1 minus 6, and compare it with -6. 7 minus 6, that's 1. Absolute value of 1 is just 1. So I'm comparing it with -6. Is it greater than -6? Oh yeah, 1's greater than -6. Sure. And I picked 1 at random, right? Remember when there's a negative number over here, after you've isolated the absolute value in the inequality, it's either always true or never true. So it doesn't matter what number you plug in to check. If it works, then they're all going to work. And if it doesn't work, then nothing's going to work. Isn't that fabulous? The only time where it might be a little weird is if it's equal to and there's a 0 on the other side, but we're talking about negative numbers right now. Okay, let me not get distracted. Last one, example D. Let f of x equal 7 plus the absolute value of 2x minus 1. Find all x for which f of x is less than 16. So I'll set it up. They want f of x, which is 7 plus absolute value 2x minus 1 is less than 16. Why don't you guys pause the video, try to solve this on your own, and then we'll go over the answer in a hot second, okay? All right, I hope you paused the video. First things first, you gotta isolate the absolute value. So subtract 7. So we have absolute value 2x minus 1 is less than 9. And since this is less than, we would write 2 inequalities with the word and between them, or we could just jump straight to the sandwich. Did you do that? Did you go straight to the sandwich? Yes, how fun. So you have 2x minus 1 less than 9 and greater than -9. And then to solve, just add 1 everywhere. And we will have -8 less than 2x less than 10. Last thing, divide by 2. So x is less than 5 and greater than -4. Wow, beautiful. They didn't say what they wanted. A graph, interval notation, I'm going to give it all, right? Let's be thorough. Here's -4. Here's 5. X is between those two numbers, right? So shade in between. Parentheses because it's strictly less than, not less than or equal to or greater than or equal to. So what would this be in interval notation? Can you see it? Yes, -4 with parentheses, comma 5 with parentheses. Beautiful. Good job, you guys. Don't forget how to do this. Unless it's something that you practice or keep up, you probably will forget, okay? So my recommendation as you're studying math, don't take any breaks. Don't take a year hiatus, otherwise you're not going to remember what you learned in the class prior, and then you're going to need to relearn it all. Maybe that's why you're here watching this video right now. So anyways, give it a thumbs up if you found it helpful. And coming up next, we're going to be solving systems of inequalities in two variables. Very thrilling.